chromium. Transition metal group 6. So possible highest oxidation number is 6 plus, similar to what we have for group 16 sulfur. This perhaps is all similarities we have. Other properties are very different. Electron configuration is 4713d5, 6 outer electrons. You can remove all of them, 5 of them, 4 of them. Very stable oxidation number is 3 plus. More or less stable is 2 plus. Name of the element is derived from Greek word chroma, meaning color. Many chromium compounds are intensely colored. Two main products of chromium ore refining are ferrochromium for stainless steel production and metallic chromium. For production of ferrochromium, chromite ore, which is iron chromium oxide, is reduced by aluminum or by carbon. In such a fashion, you have aluminum oxide and chromium and iron metal. They make an alloy. In both cases. For production of pure chromium, iron must be separated by roasting and leaching process. In this case, chromium is oxidized to hexavalent form, oxidation number 6, while iron forms stable Fe2O3. Fe2O3 is insoluble in water, and chromate ion is soluble compound. So we take starting ore, make it basic with soda, oxidize chromium with oxygen in alkaline solution to chromate. Iron dioxide falls as a solid and you have CO2. Now you reduce chromate to chromium oxide with carbon and then reduce it in next step to chromium. Chromium plus aluminum, making aluminum oxide plus chromium alternatively with carbon. Chromium makes two very stable oxides. One is CrO3, oxidation number 6, beautiful red crystals that melts at 190 degrees, soluble in water, are acidic, and they are covalent when are single molecules. In solid state, they actually make tetrahedral polymers like that, and you can see these beautiful crystals that come in when you take chromate or dichromate and acidify it with concentrated sulfuric acid. You have chromium oxide falling down as beautiful crystals. Chromium oxide can be decomposed by heating to chromium 3 oxide, Cr2O3, which is green. It is insoluble in water, has very high melting point, somehow similar to aluminum oxide, but aluminum oxide is colorless, white, and this is beautiful bright green. Actually, one of the cheapest pigments we have. If you see something big painted green, that's perhaps was chromium oxide. For bed diagram, shows that chromium 3 plus is stable in wide range of redox potentials and pHs. Only at high redox potentials and high pHs you have chromium 6 being stable. In wide range between pH 5 and 12, chromium will form chromium 2 or 3 hydrated or chromium hydroxide, solid. All other these compounds are soluble in water. Chromate ion, yellow, at high acidity forms or monoprotonated chromate. At low concentrations, at concentrations above 10 to the negative 2 molar, it forms dichromate, dimer. Beautiful red crystals if it's potassium dichromate. A very pure compound, has multiple uses in organic synthesis. Reaction with hydrogen peroxide yields beautiful peroxo compound, this composition, CrO5, 2 peroxide groups. Again, oxidation number is still 6. Chromium 3 plus has 3 electrons at D level. Because all the compounds are octahedral, they occupy the lowest 3d orbitals after octahedral splitting. They, of course, all electrons are directed in one direction, so you have 3 unpaired electrons. It's highly paramagnetic compounds. It's very stable state, so all kinetics of reaction with chromium 3 plus is very slow because of this stability. Colors are very bright. It's chromium oxide pigment and different salts of chromium. All of them are hydrated, so it's chromium 3 plus hexa-aqua complex. That's what we see here. Chromium 2 plus is relatively unstable. We'll not look